Alright, so in this one we have two girls that are racing. One is going to be running to a point 1.5 kilometers away and then turning back around. And then the other one is going to be rowing against a current of a river that has a current of 2 meters per second. And then she's going to turn around and come back with the current at 2 meters per second. Both of them have the same speed, which is 4 meters per second. Only Latoya is going to have a velocity relative to the ground based on the current she's rowing in. So we know that time is simply found by taking, if we remember our velocity equation, distance over time. We would then take velocity or distance over velocity to find our time. Adina's distance is going to be 1.5 there and 1.5 back. So in other words, 3 kilometers over her speed of 4 meters per second. So we want to make sure we have the same unit. 3 kilometers is going to be 3,000 meters over 4 meters per second, which is going to give us a unit of seconds. So we take 3,000 divided by 4. We get 750 seconds. And that's Odina's entire race time. Odina. And then we have Latoya, where she's going with the current, so her initial speed for that 1.5 kilometers or 1,500 meters is going to be at 4 meters per second plus the boost of her current, and the other direction is going to be 1,500 kilometers with the going against the current, so 4, and then the current's going to subtract, so the other half she's going to be going 2 meters per second. So the total time is going to be one leg of the journey plus the other leg of the journey. And we would just find both those times the same way. Take 1,500 for the first leg over 6.0, and for the second leg we have 1,500 over 2.0. This time is going to be 250. The other one's going to be 750. So the total time for both parts of the journey is going to be 250 plus 750, which is 1,000 seconds for Latoya, and that means that she took longer, and Odina thus wins the race. Alright, so in this problem, just like a lot of our other ones, we're just adding vectors. We know that our river flows at 3 meters per second, and our boat is trying to cross the river at 4 meters per second. So we're going to end up drifting to the right and upward. And we were just, for part A, to find the velocity of our boat, we just want to use Pythagorean theorem. V squared equals 4 squared plus 3 squared. So V is going to end up equaling 8 meters per second east. I'm sorry, northeast. And to find that angle, we're going to take we know our triangle makes I should write this 3 down here. To find that angle, we know that we can take the inverse tangent of 4 divided by 3, and that's going to give us 53 degrees. So our resultant velocity is 8.0 meters per second at 53 degrees, and that's north of east. Alright, now in this one we know the final velocity that we're trying to attain, because we're trying to go 6 meters per second due north for our resultant velocity. And in order to achieve that, we know we're heading the boat. In reality, we're heading at 53 degrees west of our northward direction. So we're driving it, steering it 53 degrees that way at some velocity in order to achieve this net velocity of 6.0 meters per second straight north. So we need to find out what the velocity of the current is that's causing us to have to. Sorry, we're assuming the current is going to be perpendicular to the direction we're going. So let me draw that a little bit out so you can see what's going on. And as you can see, we have a right triangle here. Again, we know that the river is flowing east. That's why we know that this velocity points in that direction. We also want to know the velocity of the river for part A. So we know that this angle here is 53 degrees. So that's also telling me that the full angle, since these two are going to be complementary, that this angle of the triangle would be then 37 degrees. And we know that this is 90 degrees. So finally, we can say that this angle up here, since it's also kind of an alternate interior angle to this 53, or we know that the angles of the triangle have to add up to 180, we also know that that angle is going to be 53. So now we have quite a bit of information that's going to help us solve for all of these missing pieces. I'm actually going to cheat here and find the speed of the boat relative to the water first, because I know my hypotenuse over here, the boat speed times the sine of the angle 37, and you can use any sort of Traeger geometry that you're familiar with, but I know that that's going to equal 6.0. So my boat's velocity is 6.0 over the sine of 37, or 10 meters per second, sorry. And now we know the boat's velocity, we know the resultant velocity. So the resultant velocity squared plus the river current velocity squared is equal to our boat velocity square due to the Pythagorean theorem. So 36 plus our missing velocity squared equals our boat velocity squared, which is 10 squared, or 100. So in other words, VR squared equals 64, and it looks like my velocity will end up being 8 meters per second. So we have the velocity of the current is 8 meters per second, and velocity of the boat is 10 meters per second. Again, a number of ways you could have figured that out. That was just the way that worked naturally for me. Alright, so now we're talking about a rocket in outer space that has a speed relative to somebody watching it. It's moving along there at 1.25 kilometers per second, and it's going to expel a hot gas out of the back of the rocket at 2.75 kilometers per second to propel it forward. Actually, this vector should be much longer than the first vector in the opposite direction. But basically, we're just going to add those together. We know that if the rocket were still compared to the observer would see those gases released at 2.75 kilometers per second. But since the rocket does move the opposite way with a velocity, that velocity is kind of going to slow it down a little bit to the observer. So we're going to end up with 2.75 minus 1.25 to get a final answer of 1.50 kilometers per second. Alright, so this last one, number 77, is a little bit tricky, but not too complicated if you think about it. You have the two dogs separated by 500 meters here, and they're running toward each other at the same speed of 2.5 meters per second. Since they are running at the same speed, we can safely assume they're going to meet in the middle. So when they do meet, that distance is going to be 250 meters. So we know that to find the time, we're going to take the velocity over the distance, which is, I'm sorry, the distance over the velocity, which is 250 over 2.5, and that time is going to end up being 100 seconds. That's when they meet. Now, that's also going to be the time the dragonfly is flying, because he's flying back and forth, back and forth, back and forth until they run into each other. So the time that the dragonfly is flying at that velocity of 3.0 meters per second is going to be 100 seconds. So the distance that the dragonfly travels is 3.0 times 100, because distance, remember, is equal to TV. So 3.0 times 100 is going to be 300 meters. And that's your answer for number 77.